Hi, I'm going to talk in today's lecture day 8. I'm going to break this into two parts, one where I talk about the rules, and the next one where I actually do some sample problems. And I'm doing this instead of the recording that we made earlier because it got a little bit long. I wanted to make this a little bit shorter. We start with the definition. When I do logarithms, I always write out the definition. And I use it in this form. When you have a base raised to a power is equal to a number, that's the power. And if I'm looking for this exponent, I can write it as the power is equal to the log in base b of the number. And so the base to a power is equal to a number. The power is equal to the log of base b of the number. This is the inverse that I'm finding here, which inverse operation going from an exponent to a log. And this makes perfect sense. If you think what power do you raise b to in order to equal to the number b? So base to a power is equal to a number. Well, it's 1. If you raise b to the 1 power, you get 1. So this is a rule that goes with the definition. And the second rule is this one here, which is one that you also ought to know. What power would you raise b to in order to get the number 1? And that would be to the 0 power. Of course, b cannot be equal to 0. And here we're going to say that b is a number that is greater than 1, greater than 0. Now, this is a rule or property that we talked about yesterday. The objective was to get to this point to show that these are equal to the separation of these two things. And if you think about it, this is what happens when you deal with logs and you're multiplying with the same base. So if I have m is equal to the base b raised to the x power, and I have n is equal to base b raised to the y power, I could say m times n is equal to the base of b to the x power times base b to the y power. And our property of exponents, which is the product of the same base, you can add the exponents. So this is my equivalent here in exponent form. I'm going to rewrite this as a logarithm. The log in base b of the number m is equal to x, and the log in base b, that's log, L-O-G, in base b of the number n is equal to y. And now I'm going to take this fellow and do the log of base b of this here and of this here. So the log in base b of m times n is equal to the log in base b of b raised to the power of x plus y. In a property I'm going to discuss shortly, you will see why this is what it is. But if I take the log of base b of m times n, I can say that is equal to, I'll take this exponent and move it to the front of the log. And it will show you that in just a moment why that works. I have x plus y times log of base b of b. Log of base b of b is just 1. We discussed that with our, what value do you raise b to get b? Well, you raise it to the 1 power. So here we have the log of base b of m times n is equal to, well, x, which is log of base b of m, plus y, which is log of base b of n. And there you have it. Now, if you wanted to do the difference, the quotient of properties, this would be the same thing. Here we're dividing, and we're using a minus sign instead of the plus sign. And this works for the same reason that you would do over here when we're adding the exponents, because we're multiplying with the same base. This next property is the one I was going to show you. This is the inverse property of logs. And I explain it over here. I'm going to explain it again in this space. If we start with a base raised to a power, that's b to the c power, is equal to a number, x. And we could also write this by its definition of the log. So the log of base in base b of the number, x, is equal to c. If I were to raise this power, instead of raising this to, let's start with this one. if I were to substitute for x in my value of b to the c power, I could write this as log and base b of b to the c power, and that's equal to c. If I were to substitute into this my value of x, of c, I could have b raised to the log of base b of x is equal to x. So you can see here, if I'm taking b and raising it to a log of base b, this is a negating function. This is the inverse operation. And what is it equal to? It's equal to whatever it is I'm operating it on. And the same thing goes if I'm taking the log and base b of b, that raised to a power. That's going to give me, this is an inverse operation. Here we have the exponents properties of logarithms. Now, if you think of m as a number, say b to the x. So this is going to be my number, my base to a power is equal to the number. I could write the log of base b of b to the x raised to the c power. That's the same as log of base b of b to the x times c. And that's the same thing as x times c, because the base of b to the b power, I'm bringing this to the front, and this is equal to 1. So there I have x times c. Now, if we look at this in the light of the inverse property, well, what we're going to have is that what I had, the bottom line is I can bring this c to the front and it does not change the value of the equation. And where it comes from this property of exponents. That's where this comes from. The last thing I wanted to talk about is this change of base formula. Change of base formula is important because on a calculator, you have a log key and you have a ln, the natural log. The base of the natural logarithm is e, which we will discuss on Monday. The base of the log is base 10. You don't have a base 3 or a base 4 or base 5. And if you're trying to find the base of a base 4 or 5, we need to use this property. Let's show why it works. If I were to take the log of base b of both sides of this equation, so I have a to the x is equal to log of base b of n, I can rewrite this with x on the outside is equal to log on base b of a, times log of base b of a is equal to the log of base b of n. And my x value is equal to the log in base b of n divided by the log in base b of a. Well, x, by my definition of logs, the power x, is equal to the log in base a of the number n. So this is equal to the log in base a of n. Now think about it. If b is base 10, because I have that on my calculator, I can change any log to be in base 10 using this, and that's the beauty of this. And that's the end of our discussion of properties. I'm going to do the practice exercises in another video.